This is our last planned video on the kinematics of simple harmonic motion. Thankfully, this has been tough sledding. In the last video, we dealt with figuring out what phi was in the equation for simple harmonic motion that looks something like that. And in the last video, we figured out what phi was based on what the graph looked like. This time, we want to figure out what phi is based on what the mass is doing at the assumed time equals 0. If the mass is right here at time equals 0, what's phi? If the mass is here at time equals 0, what's phi? The way I like to do this is to sketch a quick graph of this motion, and then based on the graph, we can easily figure out what phi is. So let's do that here. The graph will have x right there, and then time will be on that axis. We can see here that initially we are at a value of x equals 0, and we're told that the mass is moving to the left, which is the negative direction, which means the slope right here should be negative, which means our graph is going to be looking like that. From this point, we do what we learned to do in the last video, and that is take Bessie, the cosine cow, and put her right there under the house, right under the first positive maximum. So mentally, we're putting Bessie right there, and then we have to scoot her that way until time equals 0. That point would be okay. If you want to scoot Bessie to the left, then that would be a negative amount. And then if you want to scoot her to the equivalent point on the right, which I'll put a dot right there, that would be right there. You can see that at both of those points that have the big dot, the x value is 0 and the slope is negative. And these 2 points, aren't they, are 2 pi different from each other. So what we're seeing here is 3/4 of 2 pi in the negative direction, which is 3 pi over 2 in the negative direction. Or if we want to say phi is a positive number, we could say pi over 2. Let's try another one. Let's draw the graph of this one just real quickly. We're not going to put values on it or anything. We're just going to sketch it so we can get an idea of what things look like so that we can figure out what phi is. All right, let's look at what we're told here. It's a positive x value, but it's not a maximum. So it's maybe right there. And we're moving in the negative direction. So that means the slope here has to be negative. We're going to go down like that, and we're going to start oscillating like that. Where, once again, this point is not a maximum. It isn't a maximum, so it's the equivalent point is right there. Those are 2 pi apart. Let me put big dots there, big dots there. And as we talked about last time, to figure out what phi is, we put Bessie, the cosine cow, right there under the first positive maximum, right under the middle, and then we scoot her to the left or to the right until she bumps into those dots. And we're told in the problem, I don't want to be overly cruel, each phi should be an even multiple of 1/4 pi. So if we scoot from here to here, that would be 3 pi over 2 plus another fourth of a pi. So I'm thinking that that's going to be negative 7/4 pi. And then since the other point is going to be 2 pi different from that, but positive, then I think that has to be pi over 4. Let's try a couple more here. In this case, we are going to graph this thing, and we're told that at time equals 0, we are at a maximum negative displacement, which is right there. So our graph is going to look kind of like that. We put Bessie under the first positive maximum, and we scoot her to the left if we want a negative number, or we scoot her to the right if we want a positive number. Looks to me like it's 2 pi between this first point and that other point that I put a dot at. Phi is minus pi, or phi is plus pi. That was a pretty easy one. All right, let's try the next one. The x value that we start with is negative, but it's not a maximum, so it's right there. And in what direction are we moving? We're moving in the positive direction, so that means the slope here is positive, which means we're going to have something that looks kind of like that. Again, this is not a maximum negative displacement. So a maximum negative displacement is right there. So the equivalent point that we're looking for would be about right there, maybe. Those are the 2 points. And where does Bessie, the cosine cow, go? She goes under the first positive maximum. So we're going to scoot her 1/2 of a pi plus a fourth, 3/4 of a pi. How far would we have to scoot to the right? You figure it out. Positive 5/4 pi. Let's do some more here. Stop the video when you need to if you want to work on these on your own, but I'm not going to waste your time by providing you wait time here. All right, so what does this one look like? Here we're starting at the positive maximum, so our graph is going to look like that. And where do we put Bessie? We put her under the first positive maximum, right there. We don't have to move Bessie at all. Phi equals 0 for this case. Okay, that's nice. How about the next one? The x value is positive, but it's not a maximum, so right there. And in what direction are we moving? We're moving in the positive direction, so that means we're going to go up a bit, and then we're going to come down, and then we're going to start oscillating kind of like that. And there's one of our points right there, and then the next point, sorry, it's not a great graph, but it's right there. Those are the 2 points that we can go to. Where does Bessie start? She starts under that positive maximum. Boom, right there. If we scoot her that far, that's going to be what? 1/4 of a pi, negative. Which means how far would we have to scoot her to the right? Positive 7/4 pi. 2 more, and then we're stopping. Let's draw the graph. We're in the negative x region when we start. We're not at maximum negative, but we're negative. And which way are we moving? We're moving in the negative direction. So the slope here needs to be negative, like that. And then we're going to curve up like that. We've got that point, and then we are going to have that point right there. Those are the 2 points. And Bessie always starts in her little protective house. We're going to scoot her to the left. It's going to be negative something, and then we're going to scoot her to the right, and that'll be positive something. And how much will this be? It would be pi right to there, but then we go a fourth more, so I think negative 5/4 pi. If we scoot her to the right, it's positive 3/4. All right, last one. We're starting at x equals 0. The velocity is in the positive direction, so the slope here has to be positive. Start. Bessie starts right there under the first positive maximum. We're going to scoot her to the left to there, or we're going to scoot her to the right to there. That looks to me like that would be 1/4 of 2 pi, which I think is going to be pi over 2 in the negative direction, and 3 pi over 2 in the positive direction. If you are given the picture of how the mass is moving and where, you can draw a graph, and based on the graph, you can use Bessie the cosine cow to help you figure out what phi is. And then once you have that, then you can write the equation for the function. You can say a cosine omega t, and then for this case here, let's say minus pi over 2. Or you could write the same equation, and instead of putting minus pi over 2, you could put plus 3 pi over 2. That would be fine as well. And the amplitude, isn't this true? The amplitude you could find from the graph, couldn't you? If that graph were given, isn't that height right there? That's the amplitude, isn't it? You could put that in, boom, right there. You could also find some other things, but those are stories for another video.